Hello friends, welcome to the fifth session of a pile foundation. In this session, we will discuss the group action of a pile. Uh, Pile is not used singularly beneath the column or the wall because it is extremely difficult to drive the pile absolutely vertical and to place the foundation exactly over its center line. In actual practice, the structural load are supported by the several piles acting as a group. Load carrying capacity of a pile group is not necessarily equal to the sum of the capacity of an individual pile. It depends on the spacing of a pile. And therefore, let us discuss the significance of spacing between the piles. Now, if you see this figure, this is a single pile shown, and this is the dotted line is the nothing but the pressure bulb of a pile. This pile derives the load from the combined action of a end bearing and the friction, skin friction. And this here a pile group is shown. Three piles are there in the group. These three individual bulbs overlaps each other. This is the overlap for this pile, these two piles, and this is the overlap for these two piles, and then this is the combined pressure bulb of the pile group. When piles are spaced at a sufficient distance apart, then the group capacity may approach to the sum of the individual capacity. That means when the distance spacing is such that the bulb are not touching or they are well apart. Otherwise, when the piles are closely spaced, the stresses transmitted by the pile soil to the soil may overlap, and it may reduce the LCC of group, and then in that case the capacity is limited by the group action. Now, what is the exactly efficiency of group of a piles? Efficiency of group of a pile is defined as the ratio of a ultimate load of a group of a pile to the sum of individual loads. In the mathematical form, this is the eta g, efficiency of group, is equal to the load carrying capacity of a group, ultimate loading capacity of group, divided by the n is the number of piles and q is the load carrying capacity of individual pile, multiplied by 100 as it is expressed in the percentage, which can be also written as load carrying capacity of a group per unit pile to the load carrying capacity of an individual pile. The group efficiency depends on the spacing of a pile. Generally, the center to center distance between the pile is kept as 2.5 times b to the 3.5 times b, where the b is the diameter of a individual pile. Now, determination of group efficiency. The group efficiency can be determined by using three different formulas. The first one is the Converse-Labre formula, second one is the Los Angeles formula, and third one is the Feld rule. According to the first formula, Converse-Labre formula, the efficiency is defined as or is equal to 1 minus theta by 90 m n minus 1 plus n m minus 1 divided by mn, where theta is the tan inverse of d by s in the degrees, where d is the diameter of pile and s is the spacing of the pile. Then m is the number of rows in the pile, rows of a pile, and n is the number of piles in a row. Same way, the Los Angeles formula gives the efficiency as eta is equal to 1 minus theta by pi mns in bracket m n minus 1 plus n m minus 1 plus square root of 2 m minus 1 into n minus 1. The terminologies are same. M is the number of rows of pile and n is the number of piles in that row, and theta is the tan inverse of d by s. Then in the Feld rule, when a group is arranged in one particular configuration, then each pile in the group is assigned a 16 unit of a resistance, of which 1 unit is reduced for each of the neighboring piles in the group. And then the efficiency of group is defined as the ratio of summation of reduced units to the summation of units assigned to the piles in a group, and that is you can write down like this: summation of reduced unit qr divided by n number of piles multiplied by the 16 units assigned to the each pile. If number of piles in the group are 10, then 10 into 16, that is 160, will be there in the numerator. In this way, the efficiency of a group is determined. Now let us see how Load carrying capacity is determined when the pile group is installed into the sand and gravel. Now, first part is for the driven piles. When the piles are driven into the loose and the medium dense cohesionless soil, the group efficiency is usually high, because when we drive the pile in the loose and medium dense cohesionless soil, the pile while driving the pile displaces the soil adjoining to the loose soil adjoining to the pile, which will increase the relative density of pile, and thus the group efficiency will be high. Then first type, end, if it is an end bearing pile, particularly for driven pile bearing on the dense compact sand with a spacing equal to or greater than 3 times B, the group efficiency is generally taken equal to the sum of the individual capacity. Thus the Qg is equal to N into Qu. For spacing less than 3 times B, group efficiency is found out for the block of a pile group. This is for end bearing pile, driven pile, end bearing pile into the sand and gravel. Then the driven pile, friction pile, driven pile into the sand and gravel. In that case, the formula for efficiency is used. That is, we know the formula eta g is equal to Qgu by Nqu, and therefore Qgu is equal to eta g into Nqu, where eta g is determined. This eta g is determined like this, Qgu by Nqu, and this Qgu is how it is determined, Fs into Pg dp, as it is in the sand and gravel, divided by N Fs into P dp, in which Fs is the units frictional resistance, Pg is the perimeter of a block, dp is the length of the pile, and this small p is the perimeter of the individual pile. Then all substitute in all values in this, you'll get this Qgu, then you'll get Qu, and then you'll get eta g. If you put this eta g here, and then you'll get a load carrying capacity of a group of a friction piles into the sand and gravel. Then the bored piles. For the bored piles in a sand at a conventional spacing of a 3 times B, the group capacity is determined as Qg of U is equal to, it is taken equal to 2/3 to the 3/4 of the N into summation of individual capacity of a pile. Then for pile group in the clay, pile group in a clay, the group capacity is determined like this, Qgu is equal to, this is Qp, capital Qp, and this is capital Qs. A capital Qp is equal to Qp into Ag. Instead of AP here, it is Ag, area of base of the block, and is equal to alpha C bar into Pg into dP, where Pg is the perimeter of a block. This Ag is the area of block. This Qp is the UBC of a soil below the block. Alpha is the adhesion factor, and C is the average cohesion along the shaft of the block or the sides of a block. Then how to find out the load carrying capacity of a underrim pile in the clay? Usually the underrim piles are used in the case of clay when the soil is expansive. For an underrim pile in the clay, the capacity is determined as Qu, that is ultimate load carrying capacity, is equal to, as usual, it is Qp plus Qs. Qp is nothing but the small qp into AP, that means here it is CNC into AB, that is the area of enlarged bulb, and CA is alpha C bar into AS dash, where AS dash is the effective shaft area, and if the diameter of bulb is more, that means if bulb is quite high, then Qu is divided into two parts. The first Qp part is divided into the summation of two parts, that is pi by 4 b square into 9c, pi by 4 b1 square minus b square into 9c dash, where this c dash is the average cohesion along the enlarged bulb, plus alpha c dash into as dash, where b1 is the diameter of enlarged bulb and b is the diameter of a pile. This is all about the how to find out the load carrying